Okay, hi guys. So we'll be continuing on seeing heterogeneous chemical equations. So let's get started with some examples. So we have zinc ZnS plus 2Ag plus aqueous phase converting into Zn plus 2 aqueous plus 2 AgS in solid state. Okay, so Ag in solid state, not AgS. Okay, so we can write Kc here as again zinc plus 2 state in aqueous, zinc plus 2 in aqueous state, and then Ag plus aqueous squared. We won't be taking concentration of solid substances. Next, let us see this equation. We have Fa plus 2 aqueous plus Ag plus aqueous forming Fe plus 3 aqueous and silver in solid state. So Kc would be again Fe plus 3 aqueous divided by Fe plus 2 aqueous multiplied with Ag plus in aqueous state. Okay, next let's see this example where we have Ag2O solid plus 2 moles of HNO3 aqueous getting converted into 2 moles of AgNO3 again in aqueous phase and H2OL. Okay, so Kc for this reaction would be AgNO3 aqueous whole squared divided by HNO3 aqueous whole squared. We won't be taking into consideration the concentrations of H2OL and H2S, Ag2OS. Why? Because this is already in aqueous phase. So just note here that if substance is present in gaseous phase as well as in aqueous phase, then what will happen? So if substance is present in gaseous phase as well as in aqueous phase, then we'll be writing Kpc. We would be clubbing, in other words, Kp and Kc to have a single Kpc in case of both aqueous and gaseous phase of reactants or products in the reaction. So Kpc would be for gas combined with aqueous phase. Let's see example on the same. We have NH3 gas reacting with H2OL forming NH4 plus aqueous and OH minus aqueous. So in this case Kpc would be defined wherein you will be taking the concentrations of NH4 in aqueous, similarly OH minus in aqueous divided by concentration of not the concentration divided by partial pressure of NH3 in gaseous phase. So we are combining Kp and Kc. So Kp would be for aqueous and Kc for Kp would be for gaseous state and aqueous would be for aqueous state. So we'll be defining and coming up with a new word which is Kpc, wherein we kind of merge the concentration and the partial pressure of the substances or reactants or products, whatever may be the case. Next, let's see another example where we have zinc solid plus 2H plus aqueous combining to form H2G plus Zn plus 2 in aqueous phase. So here again Kpc would be defined as H2G, which is nothing but the pressure of H2G. So P of H2G, partial pressure of H2G multiplied with Zn plus 2 in aqueous phase divided by H plus aqueous squared. Okay, we won't be taking the concentration of ZnS. Let's see another example where we have HClG converting itself into H plus aqueous and Cl minus aqueous. Okay, so Kpc in this case would be nothing but concentration of H plus aqueous multiplied with concentration of Cl minus aqueous divided by pressure of HCl in gaseous phase. Okay, now as per thermodynamics, let me rewrite the reaction. That as per thermodynamics, we see that A times A plus B times B forms C times C plus D times T. Okay, so K equivalent in this case would be activity of C raised to the power C multiplied with activity of D raised to the power small d divided by activity of A raised to the power small a multiplied with activity of B raised to the power small b. So this is how, according to thermodynamics, K equivalent is defined, where A is activity and there is no unit for it. Okay, so let us look more deeply into the activity. So for pure solid or liquid or solvent, we can say that activity would be 1, and for an ideal gas activity would be, this is not semicolon, activity A would be pressure of gas upon standard pressure, Pi upon P naught. Okay, where Pi is pressure of gas and P naught is standard pressure, which is nothing but 1 bar. Okay, and then for an aqueous species we can write that aqueous species may be NH3 aqueous or Zn plus 2 aqueous, H plus aqueous, or OH minus aqueous. For these cases EI would be Ri into I divided by C naught. Okay, so for dilute solution R is equals to 1. Some examples here, that suppose we have N2G plus 3H2G forming 2NH3G, then we can write Kp as pressure of NH3 squared divided by pressure of N2 into pressure of H2 cube. This would be in ATM minus 2, that would be the unit of Kp. Then this is for Kp naught would be nothing but P of NH3 divided by P naught squared divided by P of N2 divided by P naught multiplied with P of H2 divided by P naught cube. Okay, so with this we come to the end of this lecture. In the next lecture we'll be seeing some more examples on writing the Kp and Kcs for different use cases. Okay, so till then, good luck and goodbye.